Hi, 7th graders, Miss Opp here. Today we're going to be learning about the area of composite figures. Let's get started. Our learning objective for today is I can find the area of composite figures. We have one new vocabulary word today, and that is composite figure, which is made up of two or more shapes. Just looking at a couple examples of composite figures here. In this first box, we have, if we were to dash this off, we have a rectangle, and then the shape on top forms a parallelogram. So this one figure is made up of a rectangle and a parallelogram. Looking at this second box, it looks to me like if we were to cut it right here, we'd have half of a circle, which is called a semicircle, and a square. So that figure is made up of a half circle and a square. Looking at this one, if we cut it right here, we have a triangle, and this four-sided quadrilateral is a trapezoid. So to find the area of a composite figure, we want to decompose the figure into shapes with areas you know how to find. So what we just did, we cut these figures where we knew it made two other shapes. Then you're going to find the sum of those areas, which we know is addition. So you are going to need to know how to find the area of a parallelogram, a triangle, a trapezoid, and a circle. A parallelogram, the formula is A equals B times H. What does that mean? The area A of a parallelogram is the product, multiplication, of any base, B, and its height, H. The area of a triangle is A equals 1/2 times B times H, which means the area of triangle A, or the area A of a triangle, is half the product of any base B and its height, H. Looking at that, if I had a square, that's a parallelogram, I would do base times height, but if it's a triangle, it's only half of that parallelogram, so that's why we cut it in half. The area of a trapezoid is A equals 1/2 H times B1 plus B2. So, looking at that, a trapezoid looks like this. Okay, the area of a trapezoid is half the product of the height. The height is down the center. And the sum of the bases, base 1 and base 2. Being that these bases, the top and the bottom, are different lengths, that's why we have to add them together. The area of a circle is A equals pi r squared, where r is the radius. So the area A of a circle is equal to pi times the square of the radius r. You need to have those written down. So now let's put that knowledge to use and find the area of a composite figure. So we're going to find the area of this composite figure. Looks to me like it's already kind of cut for us. I am going to cut this composite figure right here and make two shapes. The first shape is a semicircle, and the second shape is a triangle. So, to find the area of a semicircle, we know that area equals 1/2 pi r squared. R is the radius, but looking at what we're given, it looks like 6 is the diameter, because both of the endpoints are on the circle and it goes through the center. So I'm going to have to divide this diameter by 2 to get the radius, and the radius is 3. So plugging that radius into my area formula, I'm going to have 1/2 pi times 3 squared, which when we plug that in and we round it to the nearest tenth, we get 14 and 1/10. So the area of the semicircle is 14 and 1/10. I'm not done though. I have to find the area of the triangle. We know that the area of a triangle is 1/2 base times height. So plugging in what we know the base is 6 and the height is h. Okay, so plugging that in, we're going to have 1/2 times 6 times 11, which gives us 33. So to find the total area of the composite figure is we're going to add the area of the semicircle to the area of the triangle. When we do that, the area of the figure is 14 and 1/10 plus 33, or 47 and 1/10 square meters. Okay, so we're going to find the area of each figure below, and again, we're going to round that to the nearest tenth. So, looking at A, I'm going to cut this composite figure right along the red line to get my two shapes. My first shape is a rectangle, or on your area formulas, it's the parallelogram. And area of a parallelogram equals base times height. Looking at it, right away I can tell that 12 is my base. To find my height, I'm going to have to do some math. So, we had 12 centimeters here, but the height of the square that we took off was 6. So you just remember to add that 6 centimeters in there. So the height is 18. So plugging our base and height into our formula, we have 12 times 18, which is 216 centimeters squared. So the area of this figure is 216. Next, we have to find the area of the square that we cut off. So we have the same thing. It's a parallelogram. It's going to be area equals base times height. In this situation, our height was given 6. But looking over here, this entire distance was 18 centimeters. Right there, 18 centimeters. But the rectangle that we took off was 12 centimeters. So to find my base, I'm going to have to do 18 minus 12, which is 6. So my base is 6. Plugging that in, I have area equals 6 centimeters times 6 centimeters, and I get 36 centimeters squared. So this square was 36. So to find the area of the entire shape, I'm going to have to add these two together, the two areas together, and I get 216 centimeters squared plus 36 centimeters squared, or 252 centimeters squared. Find the area of the next two figures on your own and check back. So, looking at B, it looks like we are going to cut that figure right along this red line to make a semicircle and a rectangle. So, my first figure is a semicircle, which, looking back on our area formula, the area formula for a semicircle is 1/2 times pi times r squared. The 1/2 comes from the fact that it is a half circle, not a full circle. So plugging in what we know, we have 3.14 or pi times 7.5 squared divided by 2. When we plug that in, we get 88 and 4/10 meters squared. The 7.5 came from the diameter of 15 We know the radius is half the diameter, so we divided that by 2 to get that 7.5. The second shape is a rectangle or a parallelogram, which the formula is A equals base times height. The base is 15, the height is 7, so we're just going to plug those in. We get 7 meters times 15 meters, which is 105 meters squared. So, in adding those two areas together to find the total area for this figure, we have 88 and 4/10 for the semicircle plus 105 from the rectangle. So the total area is 193 and 4/10 meters squared. Okay, looking at C, we are going to cut this figure into two by cutting along this red dotted line to make our two figures. It looks to me like this big one's going to be a square, and this smaller figure is a trapezoid. So we cut it up, and our first figure is a trapezoid. You can kind of see that when you turn it on its side. And so it's laying the long way. You can see we have two different length bases which we can use. So the area of a trapezoid is 1/2 times h times parentheses base 1 plus base 2 and parentheses. Okay, so plugging in what we know, it's going to be 1/2 or 0.5 times the height, which is 5, because it's 5 inches tall, times base 1 is the base on top, which is 13 inches, plus base 2, base on the bottom, which is 20 inches. Okay, when you get that, you're going to simplify it to A equals 1/2 times 5 times 33, which when you solve that, you get 82 and 5/10 inches squared for the area of the trapezoid. Looking at the second shape, which looks like a square, because our base is 20 and our height is 20, we're going to plug it in. Area equals base times height, 20 times 20 equals 400 inches squared. To find the total area, we're going to add both of these together, and the area of that composite figure is 82 and 5/10 inches squared plus 400 inches squared, which is 482 and 5/10 inches squared. So let's use our knowledge on how to find the area of composite figures to solve a word problem. So the plan for the one hole of a miniature golf course is shown to the right. It is composed of a trapezoid and a parallelogram. Looking at it, right here is our trapezoid, and here is our parallelogram. How many square feet of turf will be needed for this plan? So I'm going to just draw a rough sketch of this trapezoid. So when you think of it, it's going to be slightly like that. Okay, so we have the top is 2 feet, the left side is 3 feet, and the bottom is 3 feet. Okay, we know that the area of a trapezoid is 1/2 times the height times base 1 plus base 2. This bottom corner, not in my picture, doesn't look like it, but over here you can see has a right angle, and so we know that that is the height because it's a right angle, so it goes straight up. So this 3 is our height. Base 1 is 2 feet. That's the one on top. Really switched up the colors here. And base 2 is the base on bottom, which is 3 feet. Okay? So when we plug that in, we get A equals 1/2 times 3 times 2 plus 3. On the side here, this is going to turn into 1/2 times 3 times 5. When you solve that, you get 7 5/10. So the area of this trapezoid is 7 5/10. In this parallelogram, we need to know the base and we need to know the height. We can see that the base is 6 feet. That's how long it is. But we need to decide, is this 3 feet the height or is this 2.5 feet the height? The same way with the trapezoid, the right angle tells us that that line is going straight up, which is what we're looking for with height. We want the side that goes straight up. So our height is going to be 2.5. So plugging that in, we get area equals 6 times 2 5/10, which equals 15. So to find the area of the total figure, we have to add both the areas together. So 7 5/10 plus 15 equals 22 5/10 square feet of turf needed. So now we are going to use our knowledge of finding the area of composite figures to find the area of just a shaded region. So in the figure at the right, 4 congruent triangles, or equal or the same triangles, are cut from a rectangle. Find the area of the shaded region, round to the nearest tenth if necessary. So what we are going to do in order to find just all this blue space is we are going to find the area of the full rectangle, and we're going to subtract the area of those 4 triangles away from it. So first we have to solve the area of a rectangle, which we know is length times width, or as we know it, area equals base times height. So plugging in what we know the base is 12, the height is 5. We get 12 times 5, which equals 60. So this whole rectangle, the area is 60 inches squared. Okay, but we're not done. We have to subtract away all 4 of these triangles that are not shaded. So in order to do that, we are going to find the area of the triangle using 1/2 base times height and multiply it by 4 because there are 4 triangles that we have to subtract away. So plugging in what we know, looking up here, we can see this triangle, the base is 1 inch and the height is 1 inch. So plugging that in, we get 4 times 1/2 times 1 times 1, which when we solve that, we get A equals 2. So the area of all 4 of those rectangles is 2 inches squared. So in order to find the area of just this blue area, this blue shaded region, we are going to subtract those 2 numbers. So the area of the shaded region is 60 minus 2, or 58 square inches. Don't forget, for better understanding, you can rewatch this video, you can read the examples in the book, you can YouTube the topic and find other videos on it, and as always, ask questions. Your next step is to go take the video quiz on Schoology. Here are the instructions how to do that. We are on section 7-3. Happy quizzing!